The process of architecture.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. This podcast is sponsored by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient and able to deliver world-class results. ClearMeasure is hiring architects and .NET engineers who would like a path to become architects, so just go to clearmeasure.com/careers for that. And if you have a comment or question for the show, send me an email at podcast@palermo.network. And this is a special episode. I want to interrupt our fabulous stream of expert guests to talk about a topic that I think needs to be talked about, and that is architecture. What is it? How should we think about it? And how do we approach the process of architecture? To derive the verb, how do we go about determining and implementing a fitting architecture? To architect, the verb of the word architect. If you are in this role, what is it that you do? What thought progression do you use? So I'll share some thoughts on that from 25 plus years of programming. And then I have a very special announcement at the end. So be sure to check that out. And so let's dive into it. So software architecture, a lot of people have tried to define it over time. There's a pseudo-famous definition from Martin Fowler that just drills it down to, quote, the hard stuff. And if you just do an internet search, you can find so many definitions of software architecture. But when I think about architecture, I think about the intersection of the process that we use for software and the structure that we want the software to be. And right there in that intersection is where leadership is required. Leadership produces software that ships to customers. And it's the intersection of the process we use to deliver it and the structure that we're going for. And DevOps is a core capability. Without it, you can't ship any kind of software. DevOps is about 10 years old from a terminology standpoint. And before DevOps even came into being, continuous integration, it's a book about continuous integration going back to 2006. And automated builds were a big thing that were gaining popularity in the late 90s. And of course, automated deployments in the early 2000s, all mainstays of the modern DevOps curriculum that's talked about and written about and spoken at conferences. But DevOps is a core capability of a software team. Without it, you can't ship any kind of software. It doesn't even make sense to talk about what structure you want the software system to be. You can't ship anything, even the simplest of structures, if you don't have DevOps as a capability of the team. And you might be asking questions like, I'm hearing about microservices architecture. Should I use it? Should I be using service-oriented architecture? Should I be using distributed architecture? Those are the wrong questions. And so I wanted to talk about the process of architecture. That's the right question. What is the process of architecture? What are its building blocks? How do we think about it? What is the progression from the smallest building block all the way up to the most complex of large software systems? So let's just go from the bottom. Code that we write, we're programming. Code is organized into libraries. That's assemblies in .NET, packages or jar files in Java, minified JS libraries in JavaScript. And so we'll just stick with the .NET terminology. These assemblies have to run in an executable process. But these are the lowest levels of working software that you can ship. And these libraries of code are compiled and packaged as .NET assemblies, and they need a DevOps environment. And you think, DevOps? There's no ops with a library. Well, yes, there is. There's every piece of software has some ops. For instance, our deploying to production for a library is pushing out to NuGet, pushing out to a package management system. If we never actually deploy to our customers, the customers can never use it. So if what we're shipping is a library, well, we deliver to our customers by putting it out to NuGet. And we have to have release notes, and we have to have a feedback loop. Just like if you're running a system on a production server, you have to have some type of feedback loop with telemetry that you're collecting alerts, and also some type of help desk system. So if you're delivering a library to your customers, you need to have the feedback loop, some type of help desk, even if it's just a GitHub project with issues that you watch out for. So there is DevOps in everything. It's just with libraries, it's a little bit less, and applications, it's more. So, but next level up from the library is an application. And these applications contain libraries that are both owned by the application, and then applications also depend on and include third-party libraries. And the DevOps process includes everything. The DevOps process for an application includes everything that is in a DevOps process for a library, okay? And the next level up from a single application, which might just be a library in a small console executable process, next level up is a multi-process application. It's just a bigger application. You might have a web application and a SQL Server database. Well, guess what? That's two processes. You have SQL Server running on a separate process, on a different database server, Azure SQL, and then you have your web application. That's two processes. So right away, you get to a multi-process application very, very quickly. Two things to deploy, one application. And then as you grow, you might throw in an offline job that's reading messages from a queue, and that would be your third process, but still one application, but you just now are deploying three different processes. Now, single code bases, they often have many libraries and deploy many processes. Because what I just talked about was a very simple application. Web application, SQL Server database, offline job. That's really simple. Applications grow really big. Azure DevOps itself is dozens and dozens of libraries and deployed processes, and they're grouped into 5 main sections: pipelines, artifacts, repos, boards, and test. But Microsoft has published a pretty lengthy article on the architectural journey of the Azure DevOps system in and of itself. If you've never seen that, just go search on how Azure DevOps does DevOps internally. It's a fascinating read. But large applications grow and can have as many libraries and deployed processes as you need. And with each of those, you need your DevOps environment to expand. If you don't keep up with the DevOps needs of each library, then things get difficult. But if you keep up with it, then you can continue to manage a very large application with websites, web services, offline jobs, desktop tools, mobile app UIs, etc. Many teams over the years have unfortunately failed to keep up with the DevOps needs of each of the libraries and processes of their larger applications, and then the whole of it becomes intractable and hard to work with. There's not enough separation or structural support, and then changes can be increasingly difficult to make. Now, along the way, these poorly structured applications, they came to be called monolithic. And chances are you probably heard that word. Mono means single, and lithic means of a single piece of stone or uniform or intractable, unable to be separated, without joints or seams. Okay? So it came from stonework, where you have a massive piece of stone and some sculpture is from a single piece of stone. In the software world, this is, for larger applications, it's universally bad. For very small tools or small little applications that only do one thing, no big deal. Again, if you're creating a very, very small piece of software, you don't need much architecture. You just don't, okay? When you're doing something very, very small, it's easy because almost anything will work. But as we grow, that's where our industry has a history of failed projects. And so, and software is growing. Organizations are asking more of software teams, more features, more capabilities. So chances are you're working on a pretty sophisticated piece of software that has a lot going on. And that's where we need this architecture process, so that we don't ever get to a point where our software becomes intractable, unable to be separated, without joints or seams, which is what monolithic means. Now, even a single, I'm saying this in all seriousness because there's people out there who have unfortunately discovered this. Even a single microservice meant to do a single task can become monolithic if it's intractable or unable to be separated, or if the microservice was made without joints or seams. And I'm not talking about microservices like nano services where you have a single method that's just checking on something and triggering something else. I mean, again, that's probably 10 lines of code, 20 lines of code. You don't need much for that. I'm talking about an actual autonomous service that does something significant. If those are monolithic, you're still not going to have an easy time maintaining it. But the part of the word lithic that I want to touch on, lithic, lithic, monolithic. The second part of the word lithic that's instructive is the reference to stone and without joints or seams. Single piece of stone with no joints or seams. Stone is heavy, it's hard to work with, and none of our code should be lithic in that regard, except for individual methods that do a concrete task. So if your entire piece of software is like one or two methods, you're fine. But most software is not. But besides that, everything else needs to be composed with joints, with seams, able to be separated, and needs to be able to be moved around. And so this word study makes us ask a question. If monolithic is bad, isn't polylithic bad also? Well, no, but it's all about the partitions. And in recent years, stories have been shared of, systems that are built under the guise of, the recent fad and the pendulum swing around microservices. But all of the individual processes use web services for communication, and they're all built with the same technology, and they're all kind of built the same. And in the end, they end up creating a monolithic system. They've just kind of spread it out into more pieces, but they didn't change their thinking. And so they still have a system that is kind of uniform from the same piece of stone. It's still intractable. It's still, the joints or seams are web service calls, but that's not really the joints or seams that we need. And so, unfortunately, there's more and more teams that are failing who set out to, make a nice, shiny microservices architecture, but they didn't understand why they wanted it. And so they built it in an intractable way. The next question would be, okay, well, if everything is in a single Git repository, even in a single Visual Studio solution, does that automatically make it monolithic? Well, no, it doesn't. Just that alone doesn't make it monolithic. A big application with a single library without any layers, that would certainly be monolithic. If all of our data access code was in the UI and everything's bunched together, no separation, no joints, no seams, yeah, that would be monolithic, intractable. An example is if changing something about the data, how the data is stored and retrieved, causes user interface code to have to change, well, that would be a sign that that application is monolithic. The Unix operating system, which Linux is based off of and which Windows PowerShell learned from, the Linux architecture is intentionally polylithic, and you can read a lot about that. Each piece of a Unix program is independent, but uses the Unix piping system to interact with any other Unix program, because Unix kind of created a system-level abstraction for all of the individual applications that run on Unix, and you can kind of piece them together on the command line. And well-done software is inherently polylithic. It has joints, it has seams, it's made up of many things to a strong whole. But let's get back to our architecture progression. So we talked about the libraries, we talked about applications having libraries and needing a DevOps environment. Applications have multiple libraries and deployed processes. An application's DevOps environment is geared to a unifying concept of the application.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast,
delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
Let's talk about what makes an application, not just a library. The application creates an abstraction that kind of pulls the libraries together. And so an application is greater than a library because it has abstractions and then it has configurations. And some of the libraries are going to implement the application's abstractions. In Onion architecture, which I've written about for over a decade and have spoken at multiple conferences and user groups, and Onion architecture specifies a core library or core project in a Visual Studio solution that defines those abstractions. And then your application also implements configuration normally in the startup library, okay? So an application, according to Onion architecture, would have a core library that has all the abstractions. Then it has other libraries that depend on third-party dependencies, do interesting things. And then the startup project has the application's configuration to wire everything together so that it all works together properly. And you need those two things. It configures the services collection, pulls in config from the JSON config file, and it starts the application processes, whether it's a web application, offline job, the connection string to the database, which might already be running if it's because it's a third-party dependency. But that pattern is repeated for every deployed process in the application for that process to start up, runs the configuration, pulls everything together, and sets it in motion. The next step up, the architecture progression, when you said, okay, I need some libraries. Oh, but I don't just need a library. I'm building an application composed of multiple. Well, now you might have one application and say, okay, I need more than just one application. I can continue growing this one application and have lots of different processes. But you know what? I think that's not appropriate here. I think I need a second application. And that's when you have a choice. Do you need a second application? And maybe second application depends on application 1, or you have application 2, 3, 4 that just maybe have some regular application dependencies. Or do you go up a level in architecture and say, I need a software system? And when you do that, this step is normally synchronized with your organization. If multiple software teams are involved or multiple customer types, each with significant differences, that would push you to say, you know what, I need a system architecture. And a system is made up of multiple applications that all know that they're operating within the system. If you just have 2 or 3 applications that are kind of out there and maybe one talks to the other in a certain way, that's not automatically a system because they don't know they're in a system because they're not depending on any system level abstractions. And so, management may make some PowerPoint pictures that show some type of named system of multiple applications, but architecturally, if they're not developed and tested, knowing they're part of a system, then they're just independent applications that might depend on one another. Okay, that doesn't make it architecturally so just because you draw it like that. But the same concepts and the same thinking at the application level is elevated and applied to the system level. And so just like an application has a library that has some abstractions and the startup of the application has configuration, same thing at the system level. The system is going to have a library that defines abstractions that then the other applications in the system depend on and implement the abstractions. And the system is also going to have a startup, which is going to have system level configuration that gets everything in motion. And of course, at the system level, oftentimes configuration is a lot more dynamic, data-driven. The system often allows applications to register with it. I won't go into a tangent there. But many applications are part of a system. And the system defines abstractions that all of the applications implement, or maybe only some of the applications, just depending on what the abstraction is. The system also has configuration that knows all about the applications. At the system level, configuration could be changing on the fly, and each application could change a little bit. Example, if one of the application deploys a new version, and as a result, the URL of its production server changes, the application may call into the system and update that on the fly. That's completely normal. But just because the system's configuration knows about all the applications doesn't mean that the code in the system's Git repository has a dependency on any of the applications. If you did it that way, you would move towards a monolithic system, or an intractable. It wouldn't be monolithic as in no joints or seams. It would start to become intractable. Now, you also need a DevOps environment for the system's code base, the same as for an application's code base. Okay, this is where your building blocks of a DevOps environment for an individual library that you just push to NuGet, all the building blocks of DevOps apply in the same way at the application level and at the system level. So if you get the DevOps thinking for an individual library, then you can scale that all the way up, because it's kind of recursive. It's kind of the same. It's the same concept, just applied at different levels. The application's code base may have tests that stub out a database, for example, when it's running, and certain unit tests need to stub out some data access in order to run. In a system's code base, in the Git repository for the system code, the system would have tests that stub out an application in the running of its tests. All right? And the DevOps process, again, it is the same, just applied at a higher level. And the next level higher of a system is a system of systems using the same structure. And you can see that it's kind of recursive, because the integration point tends to be just one application of the other system. When you're at the system of systems level, the applications that are going to be registered is not the whole of another system. It's going to be one of the applications of the system. So in a system of systems, that highest level system doesn't really care or know how deep it is recursive, because it all just kind of looks the same. And third-party systems are not integrated directly. Let's take a payment processor, for instance. We're going to have to use an SDK or call out to a web service for a third-party payment system. We don't want to, and this goes for applications too, we don't want to directly integrate with any third-party system. Direct integration has a long history of congealing a code base into a monolith. Instead, we create a library, and the library depends on the third-party system. And the library calls out to that system and knows how to call those web services or the SDK or whatever happens to be. And then the new library implements the internal abstraction. And at the system level or the application level will be an application abstraction. At the system level abstraction. And then the library is deployed as an application as a part of the system. And now the system has the capability to take payments. So when you step back and look at what you have from a DevOps perspective after all this, you're going to see that you have a DevOps environment for each code base. You have multiple Git repositories, and you have a DevOps environment for each Git repository. And when I say DevOps environment, you can say DevOps pipeline, whatever it happens to be, you have one for each Git repository. So for each library, application, system, you're going to have a Git repository. And for each one, you're going to have your private build, unit tests per library, integration tests per dependency, and acceptance tests per application at the highest level of the application. You're going to have an integration build for your team. You're going to have release candidate packaging and publishing of that release candidate. You're going to have a TDD environment for deployed acceptance tests or full system tests. You're going to have a UAT environment for manual tests or whatever you like to call that type of environment. And you're going to have your production environment where your customers run that application. And then you're going to have a telemetry dashboard, automated alerts, and a help desk for customer issues, problems, questions. Okay? And those are the things you have at every level. Applications tend to be a single Visual Studio solution in a single Git repository. And so That's a Git repository. It has the full DevOps environment. A library, again, doesn't need all those environments. It just needs to publish to NuGet and have a help desk. And so a few of the environments are omitted, but it still has a DevOps environment. The system is still a Git repository. The system is still a Visual Studio solution. And even the simplest of system is going to have at least 2 projects, a core library for the system level abstractions, and then another library that's the startup project, and then some test projects in there. And because it's a Git repository, it's a Visual Studio solution, that system code base is going to have a DevOps environment. So you can see a system is just an application plus. And yes, a system, the results of this system code base, it is deployed. It's very rare for a system to be so thin as to not have anything to deploy. And so almost always the system has at least one deployed process. Otherwise, applications have no way to register with it and no way to kind of use the system level of abstractions in production. So in summary, just kind of wrap this up, in order to build anything, you have to equip that code base, that piece of software, with a DevOps environment. DevOps is what enables teams to ship software. Cloud technology is nice, .NET 6 is nice, but you can use all the nice tech and tools without the right environment, and you don't get anywhere. Architectural structure of the software is secondary to the team's ability to produce any kind of software. A team on .NET version 2 with DevOps will easily outperform a team that's on .NET 6 that doesn't use DevOps. And likewise, with architecture patterns, if you don't have DevOps, no interesting architecture patterns are going to do you any good. And so to close, I wanted to share the process of architecture, the thought process, the theory behind it, and how to think about it. I think of this process akin to structural engineering. A condo, condo is kind of an apartment that you buy. A condo is basically some housing, and it needs some basics, some utilities, running water, etc. A building of condos puts a lot of them together with some shared bits. And a condo tower may have a dozen floors of multiple condos put together, multiple floors of condos with even more shared bits, kind of like an elevator, perhaps. But when you're inside one of those condos, it doesn't matter at all any of the nice features if the building falls down. And so likewise in software system, with the individual library, if you equip it with tests, a complete DevOps environment, you can compose and combine to as large of a structure as you need to. So I hope that's helpful. Send me an email with any questions, but I wanted to share the process of architecture. And now, like I promised at the beginning, I do have a exciting special announcement. We have finally launched the new video show. I've hinted at it in prior episodes a little bit, and now it's launched. There are 7 episodes live with 10 recorded. The name of the new TV show is Programming with Palmero, and it's a new internet TV show or video podcast, whatever you want to call it, and you can find it in all of the podcast directories. We syndicate it to multiple places and more to come. We syndicate it from www.polylithic.network. And yes, we syndicate it to YouTube, but we're working on adding other video aggregators as well. And so you can go to www.palmero.network and find everything there, or wherever you subscribe to video podcasts, which video podcasts are just kind of regular podcasts, RSS feeds, and all the podcast directories. But in Programming with Palmero, I teach directly. And I love to teach. It's a gift God has given me. I also program right in front of you inside Visual Studio. And part of what's already out there and what I've already produced is a multi-part .NET 6 with Onion architecture tutorial where I kind of build up the complete application from complete scratch. And from what I told you, the architectural process, I put the DevOps environment in place when it's only one library. And then we build up from there and finally have an application and add a SQL Server database. We add a Blazor WebAssembly, user interface, and each time the DevOps environment is enhanced. So that's kind of interesting. But I program right in front of you, and I also want to answer questions. And so take a look and then email me at programming@palermo.network. Just the word programming at palermo.network. That's PALERMO.network. And send me a question, send me a comment to check it out. You can subscribe, and each Tuesday a new show comes out. I have an exciting list of topics that I want to share, and so much other content is out there on tools and tech, but I wanted to teach the software knowledge and wisdom, how to think about software. And I wanted to show the actual concepts implemented. Not implemented as, oh, here's how to use tool X or here's how to use tool Y, but here's how to implement theory X or theory Y. And so when you write to me at programming@palermo.network, tell me what you think, tell me what you watch, send me a question. I may use one of your questions as inspiration to put out another episode. So, okay, that's all for now. Thank you, and thanks for subscribing to what you're listening now, the Azure DevOps Podcast. I'm your host, Jeffrey Palermo, and until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.